What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. And what we're going to be doing today in this video is we're going to learn how do we change quadratic functions from vertex form into standard form, and then how do we identify their key features algebraically. If you're just getting here, make sure you checked out my previous video. In that video, we learned about vertex form, so it's a really nice intro before we dive into what we're going to do today. Of course, make sure you hit the like and subscribe button. I'm going to throw a link to the previous video in the description below, but for now, let's get right into it. Let's review the various forms of quadratic functions. The first form we learned about was standard form. When a quadratic function is in standard form, the key piece of information that we're going to want to take out is the y-intercept. The y-intercept is always the coordinate 0, c, and the c value is always this constant when the quadratic is written in standard form. In our previous video, we learned about vertex form. Vertex form gives us two pieces of information. We can find out what the vertex is and what the axis of symmetry is. Remember that the vertex is the highest or lowest point on the graph of the parabola. What you have to keep in mind is that the vertex will have the coordinate h, k, where h is the opposite sign of whatever is inside these parentheses, and k will be the same sign of what's outside the parentheses, where the value on the inside of the parentheses represents the x value of the vertex, and the value on the outside represents the y value of the vertex. Because the vertex is always located on the axis of symmetry, the x value of the vertex is the same as x equals whatever number of the equation of the axis of symmetry. Finally, we've talked so much about factored form and different types of factoring, and factored form always looks like this. Sometimes you'll hear factored form referred to as intercept form, and that's because when you're in factored form, the key piece of information that you're going to find is the zeros, which can also be known as the x-intercepts or the roots. Just kind of like vertex form, where you have to use the opposite sign of whatever in the parentheses, the same is going to be true with factored form. When you find your factors, the roots, the zeros, the x-intercepts, they're all going to be the opposite sign of whatever is in the parentheses. Let's look at an example that can bring all of these definitions and knowledge together. In this example here, we want to write the function in both standard form and factored form. After we do so, we want to identify the vertex, the axis of symmetry, the y-intercept, and any zeros. Looking at this problem here, I can see they gave us this quadratic in vertex form. I can tell it's vertex form because you have a binomial squared with a constant on the outside. Well, when it's in vertex form, we can easily find the vertex. The x value of the vertex is the opposite sign of what's inside of this parentheses, and the y value of the vertex is the same piece as this constant on the outside. That makes the vertex here +2, -9. Because the axis of symmetry is a vertical line that the vertex is always on, it will be the equation x equals 2. Whatever your x value is of the vertex is the number that goes here in the equation of the axis of symmetry. Now we want to find another form. They gave us vertex form, but we want standard form and also factored form. To go from vertex form to standard form, all you have to do is expand this binomial here. So instead of writing x minus 2 squared, we can expand it and write x minus 2 times x minus 2. Of course, the constant of -9 didn't go anywhere, and we'll bring it down. In order to take the product of two binomials, we need to double distribute or FOIL. If we FOIL, first we'll do x times x and get x squared. X times -2 is -2x, -2 times x is -2x, and -2 times -2 is +4. We have to bring down the -9 because it didn't go anywhere. Now simply combine like terms. -2x and -2x will become -4x, and +4 and -9 will become -5. We have now successfully written the quadratic function in standard form. When a quadratic function is written in standard form, we can easily tell what the y-intercept is. The y-intercept will always be the coordinate 0, c, where c is the constant value when it's written in standard form. That makes the y-intercept here 0, -5. The last form we want to write our quadratic function in is factored form, and we know for a trinomial, factored form always looks like this. All we have to do is find the two numbers that go in these blanks, and we'll continue to use trinomial factoring. To recall, for trinomial factoring, we need to find two numbers that multiply to -5 and add to -4. Because they multiply to a negative, one will be negative and one will be positive. The two numbers that do this are -5 and +1. Place those numbers in the blank, and we have now written our quadratic function in factored form, which is also known as intercept form. They mean the same thing. Once we have the factors of x minus 5 and x plus 1, the zeros will just be the opposite of those. So if I have a factor of x minus 5, the 0 or the x-intercept will be x equals 5. If I have a factor of x plus 1, the 0 would just be x equals -1, which we can also refer to as the roots. The zeros are x-intercepts. That's all the information that this problem asks for. We have standard form, we have factored form, we have the vertex, we have the axis of symmetry, we have the y-intercept, and we have the zeros or the roots. Let's see if you could try one of these problems on your own. In this problem, you're going to take the function g of x, which is in vertex form, and write it in standard form. In order to take a quadratic function and put it in standard form from vertex form, we first need to expand it. So I'll first start by just rewriting my function g of x here. Now what we want to do is expand this. I have a binomial squared, which I can write as the product of a binomial times a binomial. Now we need to double distribute or FOIL. X times x will become x squared. X times 1 will become 1x. 1 times x is 1x. 1 times 1 is 1, and I'll bring down the -2. Now simply just combine like terms to put it in standard form. 1x plus 1x will become 2x, and 1 minus 2 is -1. Here I've placed this in standard form. There's some other key information that we should know that wasn't required in the problem that I'd like to go over. The first piece is that once we put it into standard form, we know what the y-intercept is. The y-intercept is always the coordinate 0, c, where c is the constant when it's written in standard form. What that makes the y-intercept of g of x is the coordinate 0, -1. We also said that we started with the function g of x in vertex form. When something is written in vertex form, we can tell what the vertex is by looking at what's inside the parentheses and what's on the outside. The x value of the vertex will always be the opposite side of what's on the inside, and the y value of the vertex will be the same sign as what's on the outside. That makes the vertex of this function -1, -2. The axis of symmetry is always x equals the value of the x value of the vertex, so here the axis of symmetry is the equation x equals -1. Let's try a second example. In this example here, which of the following is the y-intercept of the function v of x? Let's first start this problem by rewriting v of x. V of x right now is written in vertex form, so I can very easily find the vertex. Remember that the vertex has an x value that's the opposite sign of what's on the inside and the same sign as what's on the outside. That makes the vertex of this 10, 5. If we know the vertex, we also know the axis of symmetry. The axis of symmetry will be the equation x equals 10. Of course, this information doesn't help us solve this problem. We want the y-intercept. In order to find the y-intercept, let's take this from vertex form and write it in standard form. To write something in vertex form into standard form, simply take this binomial squared and expand it. When I expand it, it should read x minus 10 times x minus 10 plus 5. We double distribute or FOIL. X times x is x squared. X times -10 is -10x. -10 times x, -10x. -10 times -10 is +100, and bring down the plus 5. Now we just combine like terms. -10x plus -10x will become -20x, and 100 plus 5 will become 105. I've now successfully written v of x in standard form, and when something is written in standard form, the c value is always the y-intercept. Here the y-intercept will be the coordinate 0, 105. Let's try another example. In this problem, find the roots of the function f of x. Well, here they gave us f of x in vertex form, and we can find the vertex very easily. Remember that the vertex is the opposite sign of what is on the inside of the parentheses for the x value of the vertex, and the same sign as what's on the outside for the y value of the vertex. That makes the vertex here the coordinates 3, -4 with an axis of symmetry of x equals 3. Of course, this information doesn't help us solve this problem, so let's take this from vertex form and write it in standard form by expanding the binomial. Instead of writing x minus 3 squared, I'll write it as a binomial product of x minus 3 times x minus 3. If we FOIL, we should get x squared minus 3x plus 9 minus 4. If we combine like terms, negative 3x and negative 3x will become negative 6x, and 9 minus 4 is 5. We've now written this in standard form, which means we know the y-intercept. Recall the y-intercept is the coordinate 0, c, where c is the constant when it's written in standard form. That makes the y-intercept the coordinate 0, 5. Of course, we still don't have the roots of this function, so we now need to take it from standard form and write it into intercept or factored form. To do that, I'm going to use trinomial factoring, which I know will always factor like this. I just need to find the numbers that go in the blank. Well, those will be two numbers that multiply to c and add to b, where in this case c is 5 and b is negative 6. Because they multiply to a positive and add to a negative, both of these terms will be negative. In this case, the numbers are negative 1 and negative 5, so I can plug those in here, and I've now successfully written f of x in factored or intercept form. Once I have factors of x minus 5 and x minus 1, it's very easy to find the roots or the zeros. All we do is use the opposite signs of the factors. So if I have a factor of x minus 5, the root associated with that is x equals 5. If I have a factor of x minus 1, the root associated with that is x equals 1. Here the answer is choice B. Let's try another example. In this question here, find the zeros of m of x. First thing I notice is that m of x is written in vertex form, so we can easily find the vertex knowing that it's the opposite sign of what's on the inside of the parentheses for the x value of the vertex, and the y value of the vertex will be the same sign as what's on the outside. This gives us a vertex of 6, negative 4. The vertex always lies on the axis of symmetry, which is a vertical line x equals some number, and here the x value must be 6 because the vertex is on the axis of symmetry. Of course, none of this information helps us answer this problem, so let's take m of x in vertex form and change it into standard form. To do that, I'm going to expand the binomial of x minus 6 squared. Now we need to double distribute or FOIL. We'll get x squared minus 6x minus 6x plus 36 minus 4. If we combine like terms, negative 6x and negative 6x become negative 12x, and 36 minus 4 is 32. Now we've just written this in standard form. In standard form, we still don't know what the zeros or the roots are, but we do know what the y-intercept is. The y-intercept always has the coordinate 0, c, where c is the constant from when it's written in standard form. So the y-intercept here is the coordinate 0, 32. Let's take m of x and change it from standard form to factored form. Because it is a trinomial that factors, I know it's going to look like this. Now all we have to do is find the two numbers that go in the blanks, and we know that those should multiply to 32 and add to negative 12. Because they multiply to a positive and add to a negative, I know both of these numbers have to be negative. The two numbers that do that in this case are negative 4 and negative 8. Plugging those into my factored form, I now have the factored form m of x equals x minus 4 times x minus 8. Once I know that the factors are x minus 4 and x minus 8, it's very easy to find the zeros or the roots from there. They have the opposite signs of whatever the factors are. So if you have a factor of x minus 4, the root associated with that is x equals 4. And if you have a factor of x minus 8, the root associated with that is x equals 8. Let's try one final example to see if you have the hang of this. In this example, you should write the following function in both standard form and factored form. Then identify the vertex, axis of symmetry, y-intercept, and zeros. First thing that I notice here is that h of x is written in vertex form, so it's going to be very easy for us to find the vertex and the axis of symmetry. Remember that the x value of the vertex is the opposite sign of what's written inside the parentheses, and the y value of the vertex is the same sign as what's written on the outside. What that gives us is a vertex of 1, negative 16. Remember that the axis of symmetry is the equation of a vertical line that contains the vertex on it. Well, the equations of vertical lines are always x equals some number, and because the x coordinate here is 1, the equation of the axis of symmetry needs to be x equals 1. Now it's time to take this function and change it from vertex form to standard form by expanding this binomial squared. It will now read h of x equals x minus 1 times x minus 1 minus 16. Let's FOIL or double distribute. X times x is x squared, x times negative 1 is negative 1x, negative 1 times x is negative 1x, negative 1 times negative 1 is positive 1, and bring down the negative 16. Let's combine like terms to finish putting this in standard form. Negative 1x plus negative 1x gives us negative 2x, and 1 minus 16 gives us negative 15. We have now just written this function in standard form. When a quadratic function is written in standard form, we can tell what the y-intercept is. It's always the coordinate 0, c, where c is the constant when it's written in standard form. That means the y-intercept here is the coordinate 0, negative 15. Finally, let's take this from standard form and put it into factored form. Because this is a trinomial, it's going to factor to a binomial product that looks like this. All we have to do is find the two numbers that go in the blanks, and if I use trinomial factoring, those two numbers should multiply to c, which in this case is negative 15, and add to b, which is negative 2. Because we can see that we have a product that multiplies to a negative, one number needs to be negative and one number needs to be positive. Those two numbers are negative 5 and positive 3. Take those numbers and place them in the blanks, and we now have this quadratic written in factored form. To find the zeros from factored form is very easy. The zeros will have the opposite signs that the factors have. So if I have a factor of x minus 5, the zero associated with that is x equals positive 5. If I have a factor of x plus 3, the zero associated with that is x equals negative 3. There I have the zeros, and a synonym for zeros is also roots or x-intercepts. Well, that's it for this question, and that's it for me. I hope you learned a lot in this video today. I hope you learned how to take a quadratic function in vertex form and change it into standard form. Further, I hope you learned how to find all the key features of a parabola when a quadratic is written in vertex form, standard form, or factored form. Until next time.